welcome to this Processing Industry Brief. I'm Processing Magazine Editor-in-Chief Jesse Osborne, and I'm joined again today by David Brewer of SEPCO. David, thanks for joining me today, and it's great to talk to you again.
Thank you for having me. I appreciate it.
Before we get started, can you give viewers an overview of SEPCO, its products, and the markets it serves?
Absolutely. So SEPCO is simple. It's an acronym for Sealing Equipment Products Company. We are based in Alabaster, Alabama, just south of Birmingham. And we manufacture products that go into process equipment. We provide these products and solutions globally. They include products such as mechanical packing for valves and pumps, mechanical seals, thermoplastics and high performance plastics, gasket material, bearing isolators, and also today we're going to be talking about an SAS, air seals. But we provide those products globally in different industries such as pulp and paper, food processing, wastewater management, anything that has to do with processing of any type of goods. Power industry, we do that as well. One of the things that we also do, Jesse, is that we provide services such as we do equipment surveys, a lot of on-site and virtual product training, and how to, let's say, for instance, how to properly pack a pump or how to properly put on a mechanical seal. We also conduct failure analysis for all of our products, whether that's mechanical seals, whether that's packing, any of that kind of stuff. We provide those services to our end users. Usually those things are free of charge as long as they're using our products and we can gain access to their facilities. We always will provide those type of services.
Today we're going to be discussing a sealing solution for slurries and centrifugal pumps. To start things off, can you tell us about slurry sealing and why a pump application can be problematic?
Slurries in general pose problems because they are, by definition, solids that are suspended in some sort of form or another. That could be, they could be suspended in water or some other type of solvent. Typically, the very nature of pumping slurries, you are using larger centrifugal pumps than normal. What I mean by that is the pumps, they're more robust, they're larger in nature, and they pose a lot of different problems. I'm going to kind of sort of go by and show you exactly the types of problems that they have. One being that these large pieces of equipment have obviously large pipes that actually bolt to the suction side of the pump and the discharge side of the pump. Those large pipes cause what we call pipe strain. Pipe strain can then turn into where it cause excessive run out with the shaft. They also, these large pumps have different types of pump curves. Now, a pump curve is a format in which the pump, you take the speed of the motor, the size of the impeller, the viscosity or the specific gravity in which you're pumping your material, and you add all that together in a formula and it creates a pump curve. Now, the pump curve it actually looks just like, like it sounds as a curve. There's a best efficiency point on that pump curve. Now, on that best efficiency, if the pump's not pumping right, meaning it could be pumping to the left or the right of that curve, the way that happens is operators, quite frankly, they like to throttle valves back, open up valves further than they're supposed to be. That causes the pump curve to the way the pump operates to operate left or right of the best efficiency point. Now, what happens there is the shaft tends to want to jump around when they do that. When the pump cavitates or there's excessive vibration, the shaft tends to vibrate. When they do that, traditional mechanical seals and traditional packing that go into these stuffing boxes, they tend to have a hard time operating properly. Now, the mechanical seals, they have 4, maybe 5 different modes of failure potentially inside of them. They have dynamic O-rings, they have multiple springs or a spring involved. They have faces that have to stay together, and And when you add any type of vibration or movement into that shaft, those faces or the O-rings or the springs, they tend to have problems, and they tend to have hard time keeping up. So you get what we call premature failure. With packing in those applications, because we're creating a positive seal, what happens with that is we tend to get excessive wear. And the reason for that is because we are pumping slurries, which by definition are solids. Those solids could be compressible solids, like, for instance, pulp, or in a candy plant, they could be some type of flour, or some type of mixture that is compressible. But in mining, we get things like rocks and gravel and grit and grind. And when you have to seal that with packing, a lot of times your flush system that's at the facility is not adequate. It is typically it has silt in it. It's dirty. It has some sort of solids in it as well. And so you have to select a yarn or a fabric, or excuse me, a yarn or a type of packing that can sustain and that can actually pump or keep that type of material out of the stuffing box. Therefore, you get wear on your sleeve or your shaft. So those are the types of things that we see in industry today that give us problems with big, large slurry pumps. Those are the things that we work with exclusive. I've done a lot of them in mining applications and pulp and paper, and these things are always, the shaft has a tendency to move a lot, and we've addressed that with an SAS, a SEPCO SAS air seal, and we're going to get into that as well.
You just mentioned the SAS-P seal system. What are the components of the SAS-P, and how do they work together to successfully seal centrifugal pumps that are moving slurries?
So the SAS-P it's simple. It's a SEPCO air seal -P for pump. And this seal is specifically designed, this air seal is specifically designed to go into a centrifugal pump where slurries are present. And the way we do that, and some of the benefits that this provides to the end user, are as follows. So the SEPCO air seal, we had talked about in a previous one of these interviews what an air seal is and what an air seal does. But at its core, the air seal is the same as if it were to go into an auger or an agitator or a mixer. The only difference is that this seal always comes split. It will always be a split seal, and it actually will bolt up against the stuffing box. And then along with this air seal, Jesse, we will put a series of bushings. These are close tolerance bushings. SEPCO, we call them hydroloads. And we put a series of these along with a lantern ring as well inside the stuffing box. And how that works is we have a system of air that comes into the seal that is throttled down, and then so that we will not introduce air into the impeller, into the wet end of the pump, we actually through these bushing systems, we create a flush system. We actually, on the other side of the seal, we put through the lantern ring, we put a typical flush. And what we're doing, and the theory behind it, is we are actually, with the air seal, we are only sealing the flush of the pump. Does that hopefully that makes some sense. But what we're doing is we're taking, instead of sealing, we're letting the flush seal the pump itself. And then we, with the air seal, are just sealing the flush. And so it's a wonderful solution, because I can't take credit for it, but a counterpart of mine down in Texas has a saying. He says, "Air doesn't wear," and that's a great statement, because we are truly non-contacting technology with this seal. So we have no faces that are rubbing. We have no packing that is actually being a zero restriction device. We are simply using a pillow of air to seal against a flush system. And then that flush system is in turn sealing the pump itself. And this has been we've had a lot of success with this out in the field. It's a simple, but it's a very effective a way of going about sealing a centrifugal pump. I will say this. So if you took a traditional mechanical seal, and the bigger the piece of equipment, the more likely you're going to want to split that technology. So typically split seals that go into these larger piece of equipments, they have a lot of different modes of failure. For instance, you can't introduce solids across a mechanical seal face. You cannot introduce cavitation or movement. Typical mechanical seals only allow for 3 to 5 thousandths radial runout. Our seal can take over 1/4 of an inch of runout, which is a lot. That's a lot of runout. We can make up for any type of a misalignment in regards to pipe strain, in regards to cavitation and things of that nature. But our radial runout capabilities are, our TIR is over or right at 1/4 of an inch. Typical mechanical seals, anywhere from 3 to 5 thousandths runout. We don't care about any thrust. The seal does not, it doesn't care if there is 6 thousandths thrust, meaning going this way, or 6 feet of thrust. It doesn't matter. The seal will run the same either way, because it's only running on a pillow of air. So Jesse, if we are operating, if the pump, the wet end of the pump is operating at 20 PSI, what we would typically do is we would set the flush water up at 35 PSI, and then we would set the air pressure up at 45 PSI. So incrementally, we only go up about 10 to 15 PSI in between each segment. We are able to seal that pump up with non-contacting technology using that process.
What are some industries in which the SAS-P seal system is ideal?
So right now, anywhere you have slurries, I would say is ideal. But to mention a few, the pulp and paper industry, I would say, would be one of the strongest candidates out there for the SAS-P. The others would be the food and beverage industry, mining, and any type of, when you get into mining, it could be cement plants or anything of that nature, but mining, wastewater treatment, wastewater management would be another good one. But even chemical processing, I've found that in some chemical processing facilities, you have a lot of catalyst, a lot of heavy slurries, but those industries would specifically be targeted by this product.
Can you provide an example of how the SAS-P is being used in the field?
Sure. Let me give you one of my, I want to give you my specific application that I actually personally worked on. We were fortunate enough when we developed this product to have an end user that was kind enough to try this and to be a beta site for us. And that facility is it's a facility in North Carolina called Cascades. They are a recycle paper mill down in North Carolina. And we put one of these seals on a hydropulper discharge pump. And for those people who are listening to this that don't know what a hydropulper discharge pump is, a hydropulper actually basically takes paper waste like cut up magazines, brown bags, things of that nature, and it basically chops it up and turns it back into pulp before it sends it to the machine. Now, in order to get all of that recycled paper out of the pulper, it has to be sent to a pump, and that pump then shoots it somewhere else. Well, this pump specifically had a hard time because, one, it was not consistent. Like the hydropulper is constantly running, but paper is not constantly being fed into it. So that kind of goes into the point earlier where I said, you could starve a pump by, and when you do that, when you starve a pump or dry run a pump, it has a tendency to cavitate and the shaft will deflect. That was the case in this pump. It was a Goulds 3175S. and they had a tremendous amount of pipe strain, a tremendous amount of soft foot, which soft foot is sort of like what it sounds like. It's a pump volute has 2 feet on it, and if those feet are not parallel to one another and they're not perfectly horizontal, you get a little tilting either way, and that causes severe misalignment. Now, so they had that issue with this pump, and we put on our SAS-P, and we introduced the hydroload to the stuffing blocks like I showed you before. That did 2 things. It throttles the air back, but it also stabilizes the shaft. And then to boot, we had the SAS, which can take 1/4 of an inch and run out, and we were able to seal that. That was over 18 months ago, and we are still going leak free. The plant, because of COVID, we haven't been able to further this this project along, just because gaining access to the plant's sort of tough. But I talked to the area supervisor just recently, and he was very complimentary of our seal, and just spoke volumes about it, because before they had a competitor seal in there that they would only get 2 to 3 weeks out of before the seal started leaking. And then once it started leaking, they had to let it leak because they could not tear the equipment down, constantly, and they had to keep running. I mean, these plants are, they're basically, the way they make their money is on volume, and so they would just let that pump leak and leak and leak, which caused other problems, housekeeping issues, bearing failures, things of that nature. Our seal, again, 18 months, leak free. There's a lot of excitement about it, and the plant, once this COVID is over, myself and my distributor are going back in there to do the plant survey like we had talked about earlier, one of the things we offer, and we are going to put some of these seals in the places that need to have them. But we're very excited about that.
How excited was your team to learn that the SAS-P was selected as a Processing Magazine 2020 Breakthrough Products Award winner?
Well, I could say that we're super honored that that's the case. I know there is a tremendous buzz within our company. All of my colleagues and I are extraordinarily excited to get this, to use that as an accolade, and to be able to further sort of evangelizing this seal out in the market. It's very exciting to have an innovative product that we can take to the market. We can solve problems, and we can honestly say to an end user that we have a solution for you, and we are extraordinarily excited about that.
Where can people find out more about SEPCO and its sealing solutions?
So the best way to do that is to go on our website at www.sepco.com.
That concludes this processing industry brief. Thank you for watching.